The first welfare theorem says that every competitive equilibrium allocation is an efficient allocation. This is easy to see in the Edgeworth box. A competitive allocation is one where both individuals are optimizing on the same budget line within the Edgeworth box, and therefore choosing the same point within that box, with their marginal rates of substitution equal to one another, the defining characteristic of an efficient allocation. We'll now show the second welfare theorem, a theorem that says that any efficient allocation could become a competitive equilibrium allocation if we somehow figured out how to redistribute the endowment in some appropriate way. We begin with the same endowment allocation that we've worked with all along, with me getting 3 oranges and 6 bananas, and my wife getting 10 oranges and 4 bananas to start out with. Suppose we wanted to move to some arbitrary allocation on the contract curve, an allocation like the allocation D, which lies on the contract curve because the indifference curves that pass through the allocation D are tangent to one another, which implies that the allocation is efficient. Since the two indifference curves are tangent to one another at the allocation D, we can pass through D a green budget line such that both the indifference curves are also tangent to that budget line. We could similarly do this for any allocation that lies on the gray contract curve, because all of these allocations have the feature that indifference curves are tangent to one another at those allocations. I could then take any point on the green line and label it as the new endowment allocation after I have redistributed endowments from the original endowment allocation. If that is the new endowment in the economy, then the allocation D indeed becomes a competitive equilibrium allocation. Because for an allocation to be a competitive equilibrium allocation, all we have to show is that we can draw a budget line through the endowment bundle for each individual, such that both individuals end up choosing the same point in the Edgeworth box and thus have indifference curves that are tangent to one another. The slope of the green line then becomes the equilibrium price. One way to make the allocation D a competitive equilibrium allocation is therefore to redistribute from the original endowment E to the new endowment E prime. This involves taking 5 oranges and 2 bananas from my wife and giving them to me. This is of course not the only possible redistribution of the endowment that could ensure that D becomes the competitive equilibrium allocation. We could redistribute to any new bundle that lies on the green budget line as long as it stays within the Edgeworth box. Any such new endowment will allow us to draw a new budget line through that new endowment and through bundle D, with both my wife and me optimizing at the allocation D. The slope of the green budget line would remain unchanged, and therefore the equilibrium price that supports this as an equilibrium remains unchanged no matter which precise redistribution of endowment we choose to make D the competitive equilibrium allocation. The same reasoning allows us to conclude that we can support any of the points on the gray contract curve as an equilibrium allocation as long as we figure out the right redistribution of the original endowment. So long as it's possible to redistribute endowments without losing anything, there therefore is no tension between efficiency and equity. We can always choose a fairer equilibrium to implement, an equilibrium that will be efficient and that will be fairer because we've redistributed the endowment. Of course, in the real world, we don't really have efficient ways of redistributing endowments. We really don't have efficient lump sum taxes, and almost every tax we use to redistribute will create deadweight losses. Thus, in the real world, if we have equity goals that require us to redistribute, a tension between equity and efficiency does emerge because redistribution entails deadweight losses.